All right, class. So this is Algebra 1, Chapter 9 review. So we're going to review polynomials, and this is just going to be some problems, the kinds of things that you'll need to do for the test next time class meets. So don't forget, next time class meets, that's when the test will take place. I have page 400 here. So in your books, page 400 is chapter review. My advice to you is if you want additional work the odds, right? Why work the odds? Because they have the answer in the back of the book and you'll know whether or not you're practicing correctly. No sense practicing if you're not going to practice correctly. One other thought here, pause the video at any time if you want to work the problems yourself, and therefore then you can start the video when you're done and see if you got it correct, okay? So you just need to remember though, pause the video, otherwise I'm just going to explain away. All right, don't forget we started the chapter with monomials, polynomial with one term, binomials, trinomials, and then anything bigger than 3 is just a polynomial. So right here we have a trinomial, right? So if I asked you what it was, you'd say trinomial. If I asked you what is the degree, what's the degree of this polynomial, this trinomial? Okay, again, pause if you want to figure it out. So the way you figure it out is you figure out the degree of each term. The front term, don't forget that y has a 1 exponent not shown. 2 and 1 is 3. That's third. This middle term, number exponents do not count, so that's a 0. And this last term here, again, 3 for the y and 1 for the z, this is fourth. So the degree of the polynomial is the highest degree term. This is a fourth degree trinomial. Okay? So again, be careful there. You'll see some of those problems on your test, and so you want to be aware of them. All right, second situation. Remember, we did do evaluations. And so if they say evaluate 3x squared y plus 7y cubed when x equals 3 and y equals negative 2. This was my admonition to you. Everywhere where you see a variable, put a parentheses. Whoops, don't want that y, just want the parentheses. Oh, great, erased it all. So again, the 3 where the x is going, a parentheses, and where the y is going, a parentheses. Next thing is the plus, then the 7, then where the y is the parentheses and it's cubed. Now go back and place the value of the variable. So my x is 3. There's only one place where x's are. That'll go there. My y is a negative 2, so I need a negative 2 there, and I need a negative 2 there. Okay, don't forget the order of operations. Order of operations says evaluate all exponents, so I'm going to do this exponent right here and get a 9. Still have the 3. Oops, should have been black out in front. And behind it, I still have the negative 2, my plus and my 7, and now I'm going to do this exponent right here. All right, be careful. I'm going to do this on the side. Remember, this is a negative 2 times a negative 2 times a negative 2. Negative 2 times negative 2 is a positive 4, and a positive 4 times a negative 2 is a negative 8. So this parentheses is a negative 8. Okay, I can finish up. 3 times 9 is 27. 27 times negative 2 is a negative 54. Positive 7 times negative 8. 7 times 8 is 56. That's a negative 56. 54 negatives and 56 more negatives. That's 110 negatives. And that would be the solution to that. Just be careful with these. And by the way, you've got a calculator, so your calculator can be used to help yourself out. Okay, if you look at the next problem is a little interesting. So let me see if I can do my shade in reverse here. This way, yeah, you'll keep your focus where I want it to be. So if you look at this next problem, be careful. This is an addition problem, really subtraction. And so it's really adding like terms. That's really what you're doing here, adding like terms. But because of the negative here, this negative has to be distributed. A negative, and you can think of it as a negative 1 if you want. Negative 1 times x squared, negative x squared. Negative 1 times 8x, positive 8x. And a negative 1 times a negative 15, positive 15. Now all you're doing is looking for like terms, and I only have the positive 3x squareds, and the negative 1x squareds. Three positives of them and one negative of them leaves me two positives of them. Don't make the mistake of saying x to the fourth. That would be multiplication. We're not multiplying, we're adding. So I added up the two things in the blue box, and then everything else is just left. And we end up with a trinomial and a second degree trinomial. Adding like terms. Be careful. Be careful. I think I have one more of these. Yeah, so here's another one. This is an addition problem because you've got this negative in between. It would be the same thing if it was a plus sign in between. It's an addition problem. So all you're doing is adding like terms. But again, remember, with this negative, it's just like distributing a negative 1. You need the plus sign right now to keep track of everything being added. So this is a positive 4x squared. It's a positive 8xy squared. A negative now 15z, and a positive 7. And I'm going to start looking for like terms, right? Okay, I have a positive 3x squared and a positive 4x squared. That's a positive 7x squared. Those are done. I've got a negative 2 y squared x and a positive 8 xy squared. Are those like terms? And you should say yes because of the commutative property of multiplication. An x squared y is the same as an xy squared. Two negatives of them and 8 positives of them leaves me 6 positives of them. And when you write your final answer, those would go in alphabetical order. So you do the xy squared form. Okay, what else? I've got a negative 11z and a negative 15z. Negative 11z's and another negative 15 more of the z's is a negative 26z's. Oh, I'm tired right now. But so much for the z's there. And then what's left, you've got this number tacked on to the end, which is a plus 7. So we end up with a 4-term polynomial, which is really a third degree, right? Third degree because this second term is third because of the exponent of 1 and 2 for the y is 3, right? So we end up with a third degree polynomial. It's just an addition problem. Now, we get to something like 5. So you have to be very discerning. You have to look and analyze, what do I have? What do I have? So on number 5, you have a monomial times a monomial. One thing times one thing. These are straight numbers times numbers. What's a 2 times a negative 3? Negative 6. That part's done. Variable times variable. What's a squared times a cubed? Now remember, this is a to the 2 plus 3, right? And that's the shortcut. This is a to the 5th. Why is it a to the 5th? Again, let me show it to you the other way. What's a squared? A times a. What's a cubed? A times a times a. What do you end up with? A to the 5th, right? A to the 5th. And so likewise with our b's, one of them, and a b squared is 2 more of them for a total of 3 of them, b cubed, right? The negative 6, a to the 5th b cubed. Monomial times monomial. Notice the look. You've got to be able to recognize the look, right? You got a monomial times a monomial. Recognize it. Look at the difference here on number 6. A monomial, a negative 5, but it's out in front of a parentheses. A trinomial. And what word comes to your mind in this kind of problem? What word are you thinking of? I hope you're thinking distribute, right? This is just a distribute problem. Don't forget, keep the negative with the 5. Negative 5 times 3x squared, negative 15x squared. Negative 5 times negative 5x, negative times a negative is a positive. You need that plus sign to keep the proper relationship of everything. Positive 25x, negative 5 times a positive 11, negative 55. That's it. You're done. Rolling on to the next problem. But keep track of what you're doing. Look at these 3 problems again. Here, let me erase some of the stuff I did up here on this first one, on number 4. So look at number 4. The key to the whole thing is that minus sign in the middle. Tells you this is an addition problem. This is adding like terms. Here we have two parentheses together. It's multiplication, but it's a one term and a one term, a monomial times a monomial. Here now we have a monomial 1, quote unquote, times a trinomial 3 distribute. Okay? Let's go to the next kind. So you look at this and you should say, binomial times binomial, it's multiplication, right? Because they're written together with nothing in between. Look at those parentheses. There's nothing in between those parentheses. That's multiplication. That's what you're looking for. So again, what word are you thinking? You should be thinking distribute. Same word. Take the front term and distribute it to the back. 3x times x, 3x squared. 3x times the positive 6, positive 18x. Now let's distribute the negative 2. Negative 2 times x, negative 2x. And remember, I taught you guys to line up your like terms, right? And negative 2 times a positive 6 is a negative 12. Finish off the problem by adding your like terms. We got the 3x squared. 18 positives and 2 negatives leaves me 16 positives minus 12, and away we go. Okay, two binomials, distribute, distribute. All right, here's another two binomials. So I know I'm going to distribute, but I use this one to tell you to be careful about something. So let's watch our distributing. I'm going to take the 2a. Again, pause the video at any time if you want to do these yourself. What's a 2a times a 4a? I hope you say 8a squared, right? 2 times 4 is 8. A times a is a squared. All right, what's a 2a times a negative 3b? A negative 6ab, right? Okay, let's do the back here. I'll do them in green. What's a negative 5b times a positive 4a? A negative 20. Again, we'll put the a in the front and the b in the back, ab. And what is a negative 5 times a negative 3? A positive 15. And b times b. Don't forget to do the b times b is b squared. All right. Final answer, adding like terms, 8a squared. 6 negatives, right, of the ABs, and 20 more negatives of the AB for a grand total of 26 negatives of the ABs, right? Plus 15b squared, and away you go, rolling on to the next problem. Binomial times binomial. Okay. You look at number 9, and you might think to yourself, wait a minute, is that special kind of binomial? And it is. It's called a difference of two squares. But remember this, if you don't remember the pattern, it's not a big deal. Just multiply it by distributing. Just do it. It's a two binomials. Treat it that way. What's n times n? N squared. What's n times negative 11? Negative 11n. Let's distribute the positive 11. Positive 11 times n. Positive 11n. Positive 11 times negative 11, negative 121. Okay. Well, look what happens when you add your like terms. You get n squared, 11 negatives and 11 positives of them is 0 of them. And so that's gone. You just get n squared minus 121. So who cares if it's a special pattern right now at this point? It's no big deal. Just distribute and you'd be in great shape. All right, always be aware of a problem like number 10. It was on the quiz that you guys took yesterday, and here it is again. And you have to be careful. Remember, you cannot use the monomial rule on this. So we have a monomial rule, but this is a binomial. So what do you have to do? You really have to multiply the base times itself 2 times, right? And now we're just distributing. 3x times 3x, 9x squared. 3x times negative 2, negative 6x. Negative 2 times 3x, negative 6x. And negative 2 times negative 2, positive 4. Final answer, 9x squared. 6 negatives and 6 more negatives, 12 negatives, negative 12x plus 4, and there you are. Okay? Hey, be careful with that one. We've done it a few times now, but don't mess that up when you get to it on the test. All right, so you look at this and you say, oh, binomial and trinomial. What do I do with that? Here, I'm going to put my screen the other way. Binomial and trinomial, what do I do with that? Not a problem, right? That's not a problem. We're just going to simply distribute. So let me use my color here. 2a times a 4a squared. 2 times 4 is, whoa, I almost did what you guys will do sometimes. Caught myself. 2 times 4 is 8. A times a squared is a cubed. That's an 8a cubed. Second distribution. 2 times negative 3 is negative 6. A times a is a squared. Third distribution. 2 times negative 4 is negative 8 and times the a. All right, let's do the back distribution. Negative 5 times 4a squared is a negative 20a squared. Notice how I line up my a squareds. Negative 5, remember you're doing the whole negative 5, times a negative 3 is a positive 15a. And then negative 5 times negative 4 is a positive 20. All right, let's add up our like terms. 8a cubed, 6 negatives and 20 more negatives, 26 negatives. 8 negatives and 15 positives. Remember, 8 of those negatives wipe out 8 of the positives, leaving you what? 7 positives left. 7a plus 20. So let me just refresh your memory of what it takes to get a problem like this correct. You have to get the first multiplication right, the second multiplication correct, the third multiplication correct, the fourth multiplication correct, the fifth multiplication correct, the sixth multiplication correct, the seventh thing of adding like terms, and the eighth thing of adding like terms. You got the 8 things correct to get this correct. So be careful. Be neat and be careful. It's a shame to know what to do, but just make a simple mistake. You don't want to do that. There's 8 things you got to do to get that problem correct. All right, this last one I'm not going to do just for time's sake. You can do it if you want. But how would you do it? Trinomial times trinomial. Distribute, right? That times that. That times that. That times that, right? What would you do next? Take my 3x times that, my 3x times that, and my 3x times that. And what would you do lastly? Take my negative 1 times that, my negative 1 times that, and my negative 1 times that. And again, if you line everything up by like terms as you get them, it makes the finished product very easy to complete, right? You're simply multiplying by distributing. Distribute, distribute, distribute. It is the way to multiply any monomial or polynomial times polynomial. Okay? You're just distributing. Okay, 13 on, I need to give the examples because they're division and it'd be a pain to write. So remember, in your book, you've got a good amount of examples. Do the odds if you want extra problems. All right, this is 36 in the book. 21x cubed y to the fourth plus 7x squared y divided by 7xy. So what you're supposed to recognize is this. You have a polynomial on the top divided by a monomial on the bottom. That's the key there because that tells you what to do. Remember, when dividing by a monomial, you really simply divide every term of the numerator by that monomial. I've got this plus sign in between them. 7x squared y divided by that 7xy. Remember, when there's a monomial denominator, divide every term of the top by the monomial denominator. If that would have been a trinomial on the top, I'd have 3 fractions. If it would have been 4-term polynomial on the top, I'd have 4 fractions. And now just reduce the fraction. 21 divided by 7, that's easy. That's a 3. X cubed on the top divided by one of the x's on the bottom wipes out one of the x's on the top, leaves me an x squared. Let's go to red here. 4y's in the top, 1y in the bottom. The 1y in the bottom wipes out one of the 4y's in the top, 3y's left in the top. That's it. Next one. 7, anything divided by itself is 1. We're probably not going to need that. 2 x's in the top divided by 1 in the bottom leaves me 1 in the top, and then the y's are gone. So where do I end up? 3 x squared y cubed plus x. And we wouldn't write the 1. You don't need it. An x is a 1x. All right, be careful. Be careful. Be careful. Let me remind you of, I'll give you a real simplistic one. I just want to remind you of something. If you had 28a cubed, let's go minus 7a squared, all divided by a squared. So if you want to use this the short way, just split this thing up underneath each one, right? And in the front here, you're still going to have the 28. What's an a cubed divided by an a squared? 2 on the bottom, wipe out 2 of the 3 on the top, leaves you 1 on the top, right? Okay. And up. Rats. Sorry. That's what happens when you do things off the top of your head here. Here, I wanted one other thing. And what I wanted to do was I wanted a 7a squared. All right, so this would be a 7a squared, and this would be a 7a squared. So let me go back to this one. 28 divided by 7 is 4. All right, and the a is still good. So 28 goes into 7, 4, and you got a 4a in the front. All right, what I wanted to get to is this back. Please remember, this is not nothing. Anything, and you can do 7 and 7 and a squared and a squared. Anything divided by itself is 1. And please don't forget, you end up with a minus 1. Okay, 4a minus 1. Don't make that mistake, okay? Be careful. Be careful. Be careful. All right, last problem. Long division. You remember how to do it? Remember how to do it? Okay. What if we had something like this? What if we had x plus 2 divided into 4x squared minus 6x plus 8? X plus 2 divided into 4x squared minus 6x plus 8. Okay. Remember how to start. Front divided by front. What's a 4x squared divided by x? You should say a 4x. Remember, I put this 4x in the x column. Now, where do you go from here? Well, you remember you got to multiply. So it's the x times the 4x for a 4x squared, and the positive 2 times the 4x for a positive 8x. And in long division, remember, we always subtract. So don't forget to distribute this negative. So be careful here. You really have a negative 6x and a negative 8x for a negative 14x. Bring down your positive 8. What do you know? How do you know what to put up top? Again, front divided by front. Negative 14x divided by x is a negative 14. What goes up here is a negative 14. And again, remember, you got to multiply. X times negative 14, negative 14x. Positive 2 times a negative 14 is a negative 28. But remember, we are subtracting. Distribute your negative. That makes the front 0. Distribute your negative. 28 negatives and 8 more negatives. I mean, 8 positives and 28 more positives, 36 positives, right? Do you remember how to write your final answer? So it's going to be the 4x plus minus the 14, right? Then you do your plus sign. This is a plus, so the plus sign would go there. If it were a minus, the minus sign would go there. Then take the remainder, put it as the top of the fraction, and take your divisor and put it as the denominator of the fraction. Here's your final answer. 4x minus 14 plus 36 over x plus 2. All right, that's the idea. That's the main idea of the problems. There are some other things we could do, but those are the main concepts. And so be careful, review. You've got notes, you've got chapter review, you can work more problems. Do not neglect your previous test. As always, your front page is going to contain rules and short answer questions. Review that stuff. Stop missing stuff on the front page that you know the answers to, or at least they're easy to get. And then also review your problems from your old test. As always, when I have opportunity, I like to put some problems off the old test on the new test so that you're constantly reviewing. All right, enjoy your snow day and hope you guys have a great weekend. And remember, the next time algebra class meets, we will have the test over chapter 9. All right, have a great time. Bye.